So the last lesson of aromatics is learning how to build molecules using all the reactions that we have in our repertoire. So if we look, we know when you take a benzene ring and you add bromine to it, FeBr3, we will make bromobenzene. And then if you add a nitro group to it afterwards, oops, H2SO4, bromine is going to be an orthopara director. And so what you will get is you will get two different products. You'll get one with the nitro being ortho, plus one with the nitro being para. But if we did it the other direction, if we took our benzene ring and added our nitro group first, then we're putting a meta director on the ring first. And then if we add the bromine to it afterwards, we will only get one product, which would be metabromo nitrobenzene. So it's important to understand the order in which you add groups to a ring. So these are what we call synthesis problems, where we will look at trying to figure out which order to add the substituents. Before we try a couple problems, let's review one of the reactions we've already learned. We already know that when you put an acyl group on a ring, you can take that acyl group and reduce it down to an alkyl group with hydrogen and palladium. As long as that C double bond O is next to an aryl ring, this reactant will reduce it 1, 2, 3, 4, 1, 2, 3, 4. I always have to count my carbons to an alkyl group. If you look, this acyl group is right here, or right here. This would be a meta director, and then we've just changed it into an orthopara director. So we have to remember, if we want to put a substituent on the ring after the C double bond O is reduced, then it will go orthopara. If we do it before that, it will go meta. There's one other reaction we need to know. If I want to take and make a carboxylic acid, one way of doing that is taking an alkyl group. Any alkyl group that has a benzoic H can be oxidized with either dichromate or potassium permanganate. These are oxidizing agents, and they will oxidize any benzoic position as long as there's an H on the carbon to a carboxylic acid. There's no direct way of putting a carboxylic acid on a ring. You need to take an alkyl group and oxidize it. Now, if you look here, an alkyl group is an orthopara director, and the benzoic acid group is a meta director. Okay, so let's try a problem. I usually start it so you can use either benzene or toluene as your starting material. So using either benzene or toluene as your starting material, you need to figure out how to make different compounds. The first problem we're going to look at is I want to try to make a compound of acetophenone. I want to make para-bromo acetophenone. You're always going to also assume that you can separate out the ortho and para substituents or isomers. So assume that ortho and para can be separated. It's a big assumption, but we're not doing the laboratory work. We're just doing this on paper and pencil. So assume ortho and para can be separated. So if we look here, we need to add an acyl group and a bromine group. We're not going to use toluene. We'll use benzene. And because this is a meta director and bromine is an orthopara director, we're going to, and we want it overall orthopara, put the bromine on first. And then that will direct the incoming group, the acyl group, to the para position. So here is the acetyl chloride group with AlCl3. It's also good practice to remember all our reactants. So there is para-bromo acetophenone. Let's try a problem that uses one of these reactions. I want to make meta-bromo butylbenzene. 1, 2, 3, 4. So again, we're going to start out with benzene itself, not with toluene, since we don't need a methyl group. Now we have to remember, you can't put a long chain on the ring directly. So we're going to put that on as an acyl group first. So the way to do that is to take your benzene and then treat it just like we did up here with our butyl acyl group. And then you're going to add the bromine. Because this is a meta director. And after that, you will reduce the C double bond O down to the butyl group. And that will give us the product. So you always have to look at what you're aiming for and remember when to put the substituents on. The last one we're going to do is we need to make a benzoic acid. So I want to make para-bromo benzoic acid. Now in this case, we're going to start with toluene. Now we will oxidize the methyl group after we add the bromine because we want the bromine to go para. So the first step will be to add the bromine. That will go para. And then you'll oxidize the CH3 to the benzoic acid group. So dichromate. And you will get your carboxylic acid here and your bromine. If you had done it in the other order, this is a meta director. If you had done dichromate first, you would have had meta-bromo benzoic acid. So that finishes electrophilic aromatic substitution and all the reactions that go with it.